You're welcome to today's class. Today we are going to look at properties of arrays. In the last class, we started introduction to arrays. And we said an array is a collection of elements of the same data type stored in a contiguous memory location. So we are going to look at some basic properties of arrays. And I term it the DNA of an array that talks about the structure, right? So the first one I'm going to show you is what? Fixed size. Now, if I declare an array, I say int a, and I do this. So this is the size. Now, this size is fixed because this is what will help the compiler to be able to allocate memory space for the array. So the array name is a. Now, the data type of the array is integer. And integer is what? 4 bytes, right? 4 bytes. And then we have the fixed size, meaning element. This array requires 3 elements. So if each element will carry 4 bytes, it means 3 elements will carry 4 times 3. That will give you what? 12 bytes. So at compile time, the compiler will allocate memory size to this array as what? 12 bytes. So the size is fixed. Now, at runtime, you cannot increase the element of this array to 4 or 5. It will throw you an error. So that is one property, what? Fixed size. Now, 2, we have homogeneous. Homogeneous element. Now, what does this mean? Now, it means that if I'm declaring an array and assigning 3 elements to it, the 3 elements must be what? The same data type, which is what? Integer. So in this one now, if I say int a and I say 3, it means bringing this, my initializer, I am going to put 1, 2, 3. That's what I will have. Now, if I try to add 2.5 to this array, it will throw me an error because 2.5 is float and not an integer. So, and float is carrying a different data type size. So all the elements inside the initializer must be what? Carrying the same data type, which is what? Homogeneous element. That is how the compiler will be able to allocate the actual size of the array. So the third property is contiguous memory allocation. Memory allocation. Contiguous memory allocation. Now, I told you in the last class that if this is the memory and I want to assign these 3 elements of the array, so I'm having this, right? So this is what? Byte. Now, for the sake of the class, I'm just going to put the exact value there. So I'm going to assign 1. I'll put 1 here. I cannot put 2 here. If I do that, it's no longer an array. So 2 has to be what? Here. And then the 3 has to be here. So that is the meaning of contiguous. That is consecutive, side by side. Now, the address of this will be what? 100, for example. It's usually in hexadecimal. That is what it means. Now, this contiguous allocation of memory allows you to use indexing for the array. So for this first one now, I will start from index 0. The second one, I will start index 1. The third one will be what? Index 2. And then it allows for what? Pointer arithmetic, which is what? If I say p plus 1, is not exactly plus 1. What this means is using the formula of being able to identify the address of this second element, there is a formula. The formula would be address of a into I equals to base address, right? Plus I times size of, if you are not seeing, size of data type. size of data type. So if I is, that is I is index, if I is 0, size of data type, which is integer, is 4, right? And the base address is 100. You know, this array, which is A, is actually pointing to the base address of the first element. So if the base address is 100, what will be the address of this? So it will be base address, which is 100, plus index, which is 1, multiplied by what? Size of data type. And the size of integer is what? 4. So that will be what? 100 plus 4. That will be 104. So this will be 104. Now, using this same formula, this will be 108. Now, using this concept will allow you the next property, which is what? Index-based access. Now, because we are using this indexing, it allows you to access the element of this array at constant time, which means the time it takes for the compiler to access 1 is the same time it will take for the compiler to access 2. It's the same time it will take for the compiler to access 3, because it's going to jump based on the formula calculation. And that is what? Time complexity, order of 1. Constant time. That is why array is actually very nice in terms of using it as a data structure to keep your data. It will make that application to be fast, right? That is why it is being used. So index-based access allow you to use indexing. And why do we start the index from 0? Using this formula, if you put 0 here, it means that the address of the first element is the base address, which is 100. And if you use this formula, it will be correct. If you now go for the address of 1, which is the second element, which is 2, using this formula, it will be correct. But if you start from 1, then you have to do more arithmetic to actually get the answer correctly. So that is why indexing starts from 0 in order for this equation to be correct. Okay, so the next one I'm going to tell you is what? Static memory allocation. Static memory allocation. Now, same thing. When you declare an array and you assign a size to it, at compile time, memory is allocated. But at a later time, dynamic memory allocation was introduced using malloc. But when you declare an array of this nature, right, then the memory will be allocated statically. Now, 6 is what? No boundary check. This is actually the limitation of an array. Now, no boundary check. What this means is if I declare an array with 3 elements, and then I'm trying to access, if I'm now trying to access, I'm trying to access A4, it will not throw me an error. It's not going to check the boundary to say I declared size 3, and now I'm trying to access the 4th element or the 5th element. It will not throw me an error. It will give me a garbage value, meaning anything. You know, it's just like having a space. You've gotten a LAN for your project, and then nobody is coming to check the boundary. So you can actually encroach by moving into the next LAN without anybody checking. So it doesn't have boundary check. That is actually a limitation anyway. So then the 7th one I'm going to tell you is passing array to function. So you can actually pass an array to what? To a function. Meaning, if I declare an array, say in my main function, I can pass it to another function and change the value of that array, and then print out the next output, and it will be changed. So I'm going to show you that when you initialize an array and you pass values to functions or passing, I'm going to teach you a topic on this passing array to a function. So you can pass an array to a function. So these are the 7 properties I want to show you in this class. So the next class, I'm going to teach you initialization of an array, which I've actually done, but comprehensively, I will teach you that. So that is what I want you to see. Fixed size, homogeneous elements, contiguous memory allocation, index-based access, static memory allocation, no boundary check, passing array to functions. There are other properties, but these are the main 7 ones that I want to show you in this class. So don't forget to like, and do not forget to give me a thumbs up if you have not done so. So to see you in the next class. Bye-bye.